Alright, today we're going to be looking at logarithms and natural logs, natural logs, and how you can change forms with them. So first of all, what are logs? Logs are the relationship between numbers, their exponents, and what that equals. So basically, you see here 3 squared equals 9. If we were to write the log form of it, we would do first log, of course. And then first of all, what's our base? Well, we know, where's the exponent? Okay, it's right here. So that means the base is 3 right here. So that means our base would be 3. And that's why you put it as like kind of like a subscript here. And then you look at to what power. So the exponent will always be the solution. And then its result will always be next to the base. And that's how you change form. Because here, the base is 3. Because you see the exponent right there. That's the base, 3. And then 3 to its exponent equals what's next to the base. And that's 9. Because 3 squared equals 9, so 3 to that equals 9. So then 9 would be here. And then the exponent is on the other side. Because what this basically is saying is, it's asking a question. 3 to what power equals 9? That's basically what it's asking. That's what a log is. 3, and then you have your result. So how do you get from 3 to result with an exponent? And in this case, it's 2. Okay, now let's move on to natural logs. So what natural logs are is that their base is always e. What is e? E is like some number that's really, it's like just a bit under, it's like 2.7 blah blah blah. But you can just call it e. So same case here. So you see here we went from 3 to the result equals its exponent. So the same thing here. You look at e, and then that would be your result, and then that's your exponent. So then to write it out, it'd be e to the 5th equals x. Because if you look here, 3 squared equals 9, e to the 5th equals x. And then if you were to write it in logarithmic form, then you would have your base, which is, of course, the e, because the base is always the subscript. And in exponential form, that's what these are, because you see the exponents. The exponential form, the base is just what's the exponent to. So again, just a summary. That's how you were changing forms for logarithms. And this is a natural log, this is just a regular log, because what you basically do, you look at the base, you look at the exponent, you look at the result, and for log, and for changing it into logarithmic form, the base will be always what the exponent is to, and then what's next to it is going to be the result, and it's going to be equal to the exponent. So in this case, 3 squared equals 9, base is 3, result is 9, and it equals 2, which is the exponent. And in this case, we started in the logarithmic form. ln x equals 5. We know for ln natural logs, its base is always going to be e. And now you know the base is e, so you can just put the base here, e. And then to what power it is, well, it's always going to be equal to its exponent. So that's why it's going to be 5. And then x will always be the result. Whatever's next to the base is always going to be the result, which is x. And that's the exponential form. So over here, we have the exponential. These are the logarithmic forms. And yeah, that's how you change logs and their forms. All right, so here's another example where we have the logarithmic forms, because you see that log. If you ever have that symbol, so there's a logarithmic form. And it says log base 4, the base is 4 because it's a subscript. And the next one is 16, so that would be our result, like we set up here, equals 2, which would be our exponent. So writing that out, we got our base of 4. This is now we're converting it from logarithmic to exponential form. And vice versa, it would be exponential to logarithmic form if we were doing the opposite way, but we're not. So 4, and now we say what power, since we're going exponential form, what power is it 2? Well, it's always going to be equal to the power. So over here, it's 2. So 4 squared equals, what's the result? 16. And you can also check, because this really just shows the relationship between the exponent and the base to its result. So basically, you can look here and you're like, oh, 4 squared equals 16, you know? The base is 4, the exponent has to be 2, Because how can you have 4 to the 16th power? That can't even go close to 2. But anyways, yeah. You just look at the base. Next to the base will always be the results. And then on the other side of the equation will always be the exponent of the equation. So 4 squared equals 16. And that's how you change from logarithmic form to exponential form. Exponential form, you have the exponent. Logarithmic form, you have either log or natural log. And then also, I said vice versa, how you can change exponential form to logarithmic form. So yeah, that's it. That's how you change log forms and what logs are, basically. A little note I just wanted to clear up on. If they have the exponent, exponential, and if they have log or ln in front of them, they are the logarithmic form.